OK, so I apologize in advance for my voice, but bear with me. I'm super excited, voice notwithstanding, to tell you about some of the things we've been up to over the last year here in the world of Earth Engine. So I have about maybe 19 or 20 things to talk about, try to spend a minute on each, and get you out of here early. So everything I'm going to talk about is something that launched or otherwise predominantly happened since the last time many of you were here in this room a year ago. From the top. So vector data tables in the Earth Engine public data catalog. For a long time, it's been clear, though this wasn't obvious to us in the very beginning, that one of the key advantages to Earth Engine as a tool is the way it brings together a diverse range of data sets all in one place for you to just get started with. And we have this long history of having a great archive of satellite imagery and other sort of raster geospatial data, but there had been this kind of glaring gap in our data catalog for a long time, and last year was the year when we finally had a chance to tackle it seriously. As many of you know, just about a month ago, we first launched our first set of data tables in Earth Engine that are vector data, so points, lines, and polygons with attributes. Things like global ecoregions. We have in the US, tiger, road networks, census data, watershed data, glacier data, basic things like country borders. And as I think Rebecca mentioned this morning, we just literally got the ink drying on what we know has been one of your major requests for use in Earth Engine, which is the World Database of Protected Areas, which should be joining our public catalog very soon. Incredibly excited about this. One of the things it's allowed us to do also is expand the scale of tables that you can work with beyond the limits of our dear friend sister product Fusion Tables, which we've been collaborating with for many years, but as many of you know, has some limits on the size of the tables. So very excited about this new technology. And as I think you all heard this morning, literally hot off the presses, we now have the ability for you to upload your own shapefiles into that same database and bring larger scale tabular data into your Earth Engine analyses. So we're super excited to see what all of you do with that starting today. And if you're on the developer mailing list, you probably saw the email announcement about this first thing this morning, which included a mention of the fact that we know that a lot of you are actually interested in other public data sets. And we would love your requests for other data sets that we can go and get and bring into the Earth Engine public data catalog so that you don't have to worry about managing them at all. So that's things 1 and 2, our public data catalog of vector data, and now bringing your own. So I'm going to stay for a little while on the theme of data because a bunch of big things have been happening in the world of data this year. One of them that it's sort of been hard to miss if you've been in our core demographic of people processing Landsat data at scale has been the move to Landsat Collection 1. So this is something that's been really driven by the USGS, attempting to modernize and rationalize the way they distribute data and get a consistent baseline of data all processed in a consistent way for you to do things like deep time series analysis. And we've been working with them over the course of this year to figure out how we're going to bring all that data on board. So I mean, if you aren't familiar with it, the most important thing to know that's different about Collection 1 is that they have data flagged in tiers. So they have near real-time data, and then they have, once they have a chance to finish processing it, tier 1, which is the stuff that they were able to really correct well geospatially and so forth, and then tier 2 is everything else. And we're excited that at this point we're already totally caught up in Earth Engine with Landsat 7 tier 1 data, and we've actually finished downloading all of Landsat 8 tier 1. We're just fussing with some little details to get it available in Earth Engine. So at this point, you can start transitioning all your workflows over pretty confidently and know that we have the full archives available to you in an entirely Collection 1 world. Meanwhile, we've also been working with the USGS on surface reflectance data. And as you may know if you've worked with them, they've been trying to figure out exactly what their story is here. But we have also, varies by collection, we have about half the archive available for surface reflectance right now. And we're working with them to figure out, now that they've kind of got a settled story, how we can get the rest of that into Google's data centers and into your hands as quickly as possible. Landsat Collection 1 was inspired by Modis's approach to collections. So another thing we've been doing this year is following the Modis folks, moving to Modis Collection 6, and bringing in other new Modis products into the family so that you have a range of global-based products to work with. So this has included things like just the updated versions of basic MODIS products, like the surface reflectance and albedo products, vegetation products, also new products that we haven't had in Earth Engine before, for example, bringing in the other bands. MODIS has about 30 bands. Most land cover mapping is done with the 7 or so that were really designed for that use, but the others can be useful too. We now have global mosaics of the other bands. They call them the ocean bands because that was what they were designed for, but for use over land as well. And other new products that aren't actually formally part of Collection 6, but that are very exciting, like their evapotranspiration product, their net primary productivity product, all fantastic, well-calibrated global products that you can use when then diving in deeper into particular areas or doing global studies. Along the way, we've brought in some really amazing new satellite image data products. So I think everyone, their mind tends to first go to Landsat and the Sentinels, but there are some other amazing archives that we now have made available to you as well. So Aster, this was a NASA and JAXA, Japan, collaboration. This is about 1 million scenes of 13-band, 8-bit data all over the world that they just recently opened up into the public domain. So this is data going back to the year 2000 to the present day. The opening up of this catalog is in many ways analogous to the USGS's decision to open up the Landsat catalog a number of years ago. People are just now able to tap into this additional archive of data, different set of spectral bands over that 21st century period. Great stuff. Proba V, a new European satellite to do vegetation mapping. It's a 4-band vegetation mapper, gives you daily looks at 330 meters every day, 100-meter looks every 5 days with a funky 2-camera arrangement. And then VIIRS, back in the US satellite space, we're just starting to bring on VIIRS. As many of you may know, this is in some ways a kind of MODIS continuity or replacement type mission. We started with the day-night bands, with the monthly day-night composites there, because that's their band that can produce nighttime composites on a monthly cadence and even better. And you can see the changing dynamics of night lights over the world in a much finer granularity. Really amazing for people doing things like urban growth modeling or anything where you're looking where nighttime output is potentially a covariate. Lastly, of the things we've been bringing into the catalog, we've been bringing in more and more global climate data. So moving beyond land cover and land use mapping and so forth to broader climate-related mapping projects. This has included several different sort of angles on this question. So we've been bringing in, working with NOAA, their set of climate data records, or CDRs. These are extremely kind of vetted raw data sets that can come into climate models, things like data about ocean temperature fluxes and near atmospheric properties that might feed into a climate model, and similarly over land. Then on the model output side, working with our partners across the fence at NASA on bringing in the next global downscaled climate projections. So this gives you models out to 2100 that you can work with under a couple of different climate scenarios. You get an ensemble of model outputs downscaled to a really convenient global resolution, great for doing anything that involves forecasting of climate-related variables out to the future. And other things are climate-related things, things like WorldClim and BioClim. This is a take on climate that's more geared towards understanding how climate variability informs things like species habitat distribution. So you get at the characteristic properties of climate varying over the planet. So a lot of really exciting climate-related data. These are all just raw materials that I've been excited to see people doing amazing things with over the course of the last year. Speaking of amazing things done and then bridging the topics, so this year we were extremely thrilled to work with a European Joint Research Center on the Global Surface Water Project that was published in Nature earlier this year. This is exciting because it was both built in Earth Engine and now is back available in Earth Engine for everyone to do downstream analysis on. So anything that might be informed by the variability of surface water on the Earth year to year, month to month. It's a fantastic data set that you can use as inputs to your own work now. or take as inspiration for the kinds of primary science you might want to do by mining the raw Landsat or Sentinel archives with Earth Engine. Among the other things that we've been doing with Earth Engine, we produced this year an updated version of our global time-lapse animations. This year, there were a couple things that were different. One is we were able to improve the atmosphere correction and cloud removal techniques, and we were able to bring in Sentinel data for the recent years, so the last few years get quite crisp visually, so you can see what was going on in the years leading up. And even more interestingly for us, this time, unlike last time, we were able to do this entirely using the exact same scripting environment that you use, right? So when we first did this a number of years ago, this was using a bunch of internal hackery to develop that script. That became inspiration for our own work in the years since, to get to the point where now anyone can write and run the exact same algorithms to mine that Landsat and Sentinel archive and produce the same sequence of frames as we were doing. So that was fun. So shifting behind the scenes a little bit, one of the things that we've been doing is just continuing to keep up with all of you. It is a constant source of entertainment to see what new and exciting adversarial script someone has come up with. One of the things that makes Earth Engine as a platform so much fun to use, I find, is that within just a few lines of code, I can write something that varies from just a very simple, let's display some data on the map, up to something that may be orders and orders of magnitude more computationally expensive. So that means that when a query comes into Earth Engine, with incredibly wide range of resources required by that query, and we have to figure out how to accommodate that. So this is a constant struggle. In the past year, we've been doing a bunch of work in particular around things like recognizing when there are particular functions that are causing internal errors and trying to get at them before you even notice that you're having that problem, or also just allowing you to run bigger jobs. I'll say more about that in a bit. And in particular, we've been doing a bunch of work that has not quite yet fully paid off, but will be paying off soon, revamping our underlying metadata database, so that many of the underlying queries that are sort of happening behind the scenes happen faster and with higher reliability, which will, I think, have ripple effects throughout the system that we're very excited about. So speaking of the expensive things that you guys are doing with our computational platform, there have been some exciting additions to our library of processing functions, starting with unsupervised classification. This had been a long-standing request for people who are accustomed to using this tool in a conventional sort of desktop image processing environment. It had been a big gap in Earth Engine. We now have a number of clustering tools, including a few different variations on k-means, as well as learning vector quantization, LVQ, a function called cobweb. And you can use these to take a scene, a multispectral scene, and have it automatically decide, based on that spectral content, how to categorize the pixels into some controllable number of categories. And you can then figure out subsequently how to classify each of those categories. It can be a great tool in the machine learning toolkit. We've been adding a lot of other functions related to image processing, and so a couple things. What we're looking at here, this is, I believe, the Nevada-Arizona border, roughly. And this is a pretty standard spectral unmixing. So vegetation, non-vegetation, land, and then water. But what's different and what's new is we're just adding the ability to do constrained unmixing. So sum-to-one constraint, non-negativity constraint. These are some of the mathematical operations we've been adding. Others that we've launched in the last year include things like a fast distance transform, so you can efficiently compute the distance from some set of points to all the other points. Also a medial axis function, so if you're trying to take, for example, a river network was the original application. You have some linear sets of features, and you want to really understand what is that topology. You can extract that. All of these functions that we add, these are all based on your requests, right? So in the beginning, there were a lot of obvious glaring omissions. We could just go kind of fill things in ourselves. At this point, we've hit most of the low-hanging fruit, and it's really all driven by you coming to us saying, wow, if you had this other little function, suddenly this paper that I want to implement, this workflow that I want to explore would become possible, and then we add it to our queue. So please keep your requests coming. So this extends even to fundamental stuff. We've been slowly fleshing out this API. For example, a year ago, you could apply reducers in lots of ways, but one thing you couldn't do was apply a reducer to a list of values. OK, it just hadn't occurred to us that you might want to do that. It was easy to add once someone asked. Meanwhile, we've been adding things like much more powerful or flexible tools for computing histograms, or better tools for working with array-valued images. These are all just requests that solve specific problems that came up over the last year. And we're always excited to have a real use case. That's nothing quite so inspiring for one of our engineers as a real human who will really use this function if only they write it. So meanwhile, once you've got your analysis script written, you want to export your data. We've been doing a number of things, both behind the scenes and visible to you, to help these run bigger and better. So for example, as I was mentioning during my cloud session earlier this morning, a month or two ago, we were working on exporting the newest version of the Hancher global forest change analysis. So we had a global asset in Earth Engine. We wanted to produce a bunch of geotiffs. But we had some very specific requirements. We wanted to export a set of geotiffs where each one was exactly a 10 by 10 degree tile. And that was the sort of thing that a year ago required me to manually construct each one of those exports separately in order to have that control. Now there are tools when you export a single image to very precisely control how it gets tiled up. This is an example of a sort of a simple sounding new feature that makes it much easier to work with computing and exporting big data sets in Earth Engine. Those of you who were here a year ago know that this is just a tiniest bit of a cheat because we previewed this one for you all 1 year ago today, 1 year ago the summit, and then it launched a couple weeks later. So it's been really fun to watch over the course of the last year how users using the user interface API have begun to use Earth Engine in a really new and different way. So now instead of every user having to write code, edit code, run those scripts, a single code author can write a script and package it up in this user interface that allows other users to then explore data, ask questions without having to change code, write code at all. So this was a sort of pale screenshot of a tool that we've been working on for comparing a bunch of population data sets where you can quickly bring up a few different data sets and adjust how they're displayed and pan and zoom around and do that kind of interactive visual comparison. And it's just a short Earth Engine script to generate this behind the scenes. So plug to go to Andrew and Lauren's Earth Engine user interface class if this idea sounds interesting to you. Similarly, been incredibly excited to watch what's been happening with Python and Jupyter notebooks and Datalab over the course of the last year. Big thanks to Tyler, whose Python class you can go to while you're here, for doing a bunch of work packaging that up in a way that makes it much more usable than it was when I was first talking about it here a year ago. So there's just a container image that you can run on cloud and you're up and running. And he's been building tools to do things like this is a Slippy map embedded inside of a Datalab environment, so you can explore your data in a much richer way within Datalab than you could a year ago. And in my view, for certain kinds of data science, this is the future because of how well you can control both Earth Engine and other tools like TensorFlow and Cloud Machine Learning Engine from within a single Python environment. So I think watch this space in particular over the coming year if you're interested in machine learning. This is going to be a great tool for combining the various platforms that we have that you can use in that space. So a couple more things. Along those lines, we've been doing some work in the last year to make it easier to run your analyses that you don't want to run in Earth Engine. Right? Earth Engine is a tool. It does certain kinds of analysis better than anything. It also has a unique data catalog that is useful for other kinds of analysis too. So one thing we did this year first was we took our archives of Sentinel and Landsat data, Sentinel-2 and Landsat data, and made them also available to other Google Cloud users through the Google Cloud Public Datasets program. But that was, in a way, a stopgap measure. For those two data sets, there's a tremendous amount of open source code that knows how to work with those data sets, and people can just operate with them in their standard form. If you look across the Earth Engine data catalog, a lot of those data sets come in esoteric formats where only the expert in that particular domain has any idea what to do with that thing. Whereas Earth Engine already has all these data sets normalized into a consistent form. So what we're working on now, and that we actually have available in early access, so if this is of interest to you, reach out and we can try to get you involved early in the process, is a new set of APIs that are geared specifically towards taking that data in Earth Engine's data catalog and querying it from elsewhere in Cloud Platform. So that might be a custom job that you're writing in Dataflow. That might be a cloud machine learning engine job running some TensorFlow model. Pulling data from all of these different Earth Engine data sets efficiently into those computations running outside of Earth Engine. So this is all about making it easier and easier to run powerful hybrid analyses that really make the best use of different tools in our cloud platform. And finally, one of the things we've been excited to work on this year has been working with our first few commercial pilot customers. So as many of you know, we've all been in this business primarily to support researchers doing amazing things for public benefit. Along the way, we've also had many people asking us, can I use this for commercial use? Or even if I'm doing non-commercial use, can I pay you for the kinds of contractual relationships that I'm accustomed to having or that my manager requires me to have in place? And so in order to support these different use cases, we've been very slowly and carefully establishing a commercial program. If you are now interested in using us commercially in a couple countries, including the US, we have now a mechanism to do that. If you're interested from other countries, we still want to be talking to you so that we can support all these different use cases, commercial as well as non-commercial. We have a couple of new things that happened not in Earth Engine itself, but around Earth Engine that make it easier for all of you to do amazing things that I wanted to plug on the way out here. The first is we launched our first few self-guided tutorials that take some particular topic area. These are examples from looking at global forest change and looking at global surface water variability. And they use these as sort of a lens through which to look at introducing various Earth Engine concepts. Highly recommended, thanks to our great DevRel and outreach teams who are working on some of this content. These are just available on our main developer documentation website. There's a tutorials tab now. And in a similar vein, incredibly excited that we have now launched our channel on Medium, the sort of blogging ecosystem. We have a channel all about Earth and Earth Engine aimed at developers, scientists, explorers, and storytellers. If you are any of those things, I encourage you to subscribe to this channel. We post there sometimes now. Also, our partners post there talking about interesting case studies that I've learned a lot from reading about. So we've had just recently examples in areas like public health or highly technical topics like how to use Otsu's method for image segmentation. It's quite a wide range. And very excited to see all of the other content, some of which I imagine some of you will be writing, and that we can help bring eyeballs to through this channel over the coming year. So with that, I know it's been a long day. Thank you all for bearing with me. And happy hacking, and somebody will tell us what's next. Okay. I believe today, if you go and get the latest version of the Python command line tool, you should now have an upload table function. You pointed at the sort of main shapefile, the .shp file on cloud storage.
Yeah, like
and
a zip, right?
you can either it can be a zip, or you can have the whole shapefile, which is several files. They can be sitting next to each other on cloud storage, and so you just point it at the main file, the .shp file, and it will use the sidecar files automatically.